In Lesson 2.7, the target states, I can compare and order fractions and decimals. For this lesson, we're going to review several things you're going to need to remember to compare fractions, mixed numbers, positive and negative fractions and mixed numbers, and to compare decimals. Let's take a look at a common way to start thinking about this problem, and that's comparing two numbers with the same denominator. For instance, we're going to compare 4/9 and 7/9. To compare 4/9 and 7/9, you'll notice that they're both ninths. They both have the same denominator. So if we look at what 4/9 looks like, if I had a tile broken into 9 sections, 4/9 would be 4 of them. And if I had the same tile, but this time I was looking at 7 of the 9 sections in the tile, or the strip, what I can see is that 7/9 is greater than 4/9. 7/9 would be greater than 4/9. So in other words, 4/9 would be less than 7/9. And I can see that since both of my fractions are ninths, they both have a denominator of 9, I'm really just comparing the numerators. And 4 is less than 7. That's a good way to go when you're thinking about comparing fractions. If I'm going to compare 5/6 to 7/10, 5/6 and 7/10 are harder to compare because they don't have a common denominator. But I can easily rewrite fractions to make them have a common denominator. I just have to think of the common multiple of 6 and 10. Where do 6 and 10 meet if I multiply to greater numbers? 6 can become 12, 18, 24, 30. 6 becomes 30. You might have thought 60. Yep, 60 is a common denominator for 5, 6, and 7/10. But 30 is the least common multiple of 6 and 10. 6 can become 30 if I multiply it times 5. Whatever I do to the denominator, I have to do to the numerator. So if I multiply 6 times 5, I have to multiply 5 times 5. So 5/6 is 25/30. To turn 10 into 30, I multiplied it by 3. So to turn the denominator into 30, I'd also have to do the same to the numerator, multiply it by 3 to get 21. So now, as you can see, I have common denominators. So now I'm only going to think about comparing my numerators. Which is greater, 25 or 21? Well, 25 is greater than 21, so 5/6 is greater than 7/10. Take a look at one more example. -3/5 and -5/9. They're both negative. So I'm looking for the one that's a smaller negative or the one that's closer to 0. But it's hard to compare a fraction with the denominator of 5 to a fraction with a denominator of 9. So I'm going to look for a common multiple of 5 and 9. Where do 5 and 9 meet? Well, it happens to be 5 times 9, or 45. They can both become 45. Nine times 5 is 45, so I have to do the same thing to the top. So I'm looking at -5 times 5, or -25/45. On the other side, 5 times 9 gave me 45, so I have to do the same thing to the top. -3 times 9 is -27. So now I'm comparing two numbers with the same denominator. I'm looking at the numerators. Which one is greater, -27 or -25? Well, the one closer to 0 is greater. The one further to the left of 0 is smaller. So -27 is less than -25. So -3/5 is less than -5/9. So being able to find a common denominator and rewrite fractions, rewrite equal fractions with a common denominator so you can compare the numerators is an important skill. Let's take a look at the last part of this target. It's not only comparing fractions, it's also comparing decimals. I like to think about decimals in terms of money. I think money is a really easy way to think about this pretty often. If I'm looking at 0.84 and 0.81, if I think about money, how much money is 0.84? It's 84 cents. to 84 hundredths of a dollar and 81 cents on the other side. It's easy to compare these two numbers if I think about money, because 0.84 is greater than 0.81. Another situation that might come up is with repeating decimals. In this case, 0.34 with a repeating 4 and 0.342, it's a terminating decimal, so it just ends at the 2, might be tricky. I would want to think about what does 0.34 with a repeating 4 look like. I at least would want to think about extending it one more place, because 0.342 also goes one more place. A really good strategy for comparing decimals is to line them up like this, and they both have 0 in the ones place, a 3 in the tenths place, a 4 in the hundredths place. So now we're looking at the thousandths place. Which one is greater? The 3, 4, repeating 4 is greater. So 0.34 repeating is greater than 0.342. I could have done that with 0.84 and 0.81. If I line them up and cancel, I'm looking for the place value that helps me determine which one's greater. They both have 8 in the tenths place. The 4 is bigger than the 1, so that's what gave me 0.84 being greater. Okay, now you try. Click pause and solve each problem. There's 4 problems here and they're all different. Number 1 and 2, you're comparing fractions, so figure out which fraction is greater than or less than and insert the greater than or less than symbol. For number 3 and 4, you're comparing decimals. So use the strategy of stacking the decimals on top of each other. Look at the repeating symbols closely and try to figure out what the next places would be in the decimal. For number 4, order the numbers from least to greatest. Find which one's the smallest and put it on the left, and put them in order from the smallest one to the largest one. Good luck. Okay, for number 1, -5/8 and -7/8, they have a common denominator. They're both eighths. So really all we need to focus on is the numerator. So really the question is, what's greater, -5 or -7? Which one's closer to 0, or which one's further to the right on a number line? -5 is just a little bit greater than -7, so -5/8 would be greater than -7/8. For number 2, 3 3/5 and 3 2/3, I probably would have to do some decimal conversions. I'm going to rewrite each one as a decimal. I could rewrite the fractions that have a common denominator, but since I know both of these fractions, 3/5 is 0.6, so it's 3.6. And 2/3 is 0.66, so that's 3.66, and it's a repeating 6. So 3.6 is less than 3.66. So back to my original question, 3 3/5 is less than 3 2/3. Okay, number 3. 0.46 repeating and 0.45 repeating 5. Sometimes it's helpful to write the number a little further. 0.4646, at least a few places, and 0.4555. So now I can compare place values. If it helps, you can stack them on top of each other, 0.4555, because I can compare places. 0 in the ones place, they both have a 4 in the tenths place. This one has a 6 in the hundredths place. So the repeating 4/6 is greater than, because the 6 is bigger than the 5, 0.46 is repeating is greater than 0.45 with the repeating 5. Number 4, order these 3 numbers from least to greatest. They're all really close together, but one of them is written as a fraction. So it would be helpful to write them all in the same form. So this one I want to look at more closely. It's 7575. This one 0.755. And 6/8 is also 3/4. If I reduce it, it's 3/4. So it's 0.75. And it terminates. It ends. So it might be helpful to stack these numbers on top of each other. 0.755 and 0.75. So they have a lot in common. So this is a tricky question. They all have a 0 in the ones place, a 7 in the tenths place, a 5 in the hundreds place. Yee. I have to add some zeros here just to make this a little bit easier. So now I'm looking at the thousands place to decide which one's the greatest. So this one is the greatest because 7 is greater than 5 and greater than 0. So 0.75, repeating 75 was oops, I should write that one on the left. Let me erase that. 0.75 with the repeating 75 is the biggest number. The smallest number is this one because it has a 0. So 0. Or 6/8. 6/8 was the least. So 6/8 is less than 0.755, which is, running out of room here, which is less than 0.75 with a repeating 75. How'd you do? Check your answers.